So the first thing we want to do with this one is check to see that it's factored. It is in fact factored, which is helpful for us. Next step is going to be to find the domain. So we want to find the excluded values, or the values that'll make the denominator 0. We can see there's 1 right there, and that's value. It is a factor of 3x, but if I set it equal to 0, divide both sides by 3, we find that x is equal to 0 is one of the values that will make that denominator 0, so we need to exclude that one. And then the factor of x plus 2 will give us the fact that -2 would 0 that factor out, which would make the denominator 0. So we actually have two values we need to exclude. We need to exclude -2 and 0. Everything else is okay on the number line. So we can see that when we write this out on the number line, we're going to actually have 3 intervals in our interval notation. -∞ to -2, -2 to 0, 0 to infinity. All right, equations of vertical asymptotes. Before I go take a look at the vertical asymptotes, I'm actually going to look for holes first. So we're going to take care of step B, and then we'll come back, or C, and then come back to B. And we haven't really seen anything like this one before, but we do know x is a factor. So there is a common factor of x in the numerator and the denominator, which tells us that this rational function has a hole at x equals 0. Now, from that point, I'm going to get rid of my number line over here. We're going to actually be working with a new reduced form of the function, which is going to be -x minus 2 over 3x plus 2. Now, we know that the hole is at x equals 0, but we need to find the y value of the hole. Find the y value of the hole, we substitute into the reduced form of the equation. So y is equal to -0 minus 2 over 3 parentheses 0 plus 2. Now this one's a little difficult. I mean, not difficult, but just like we have to mine that negative out in front of the fraction and deal with that at a certain point. 0 minus 2 is -2. And then on the bottom we have 3 parentheses 0 plus 2 gives us 2. So we're going to get negative, and then we're going to have a -2 on top and a 6 on the bottom. All right. So negative, this is going to flip this over to a positive 2 over 6, which we can reduce to 1/3. So the location of the hole is at 0, 1/3. Equation of the vertical asymptote. Now that we've checked for holes, the vertical asymptote occurs at the other factor that's in the denominator. So x plus 2 is the factor that's in the denominator, so there is a vertical asymptote at x equals -2. All right. Now, for a horizontal or oblique asymptote, we are looking at the degree of the numerator and the degree of the denominator. When I take a look at this one, it really doesn't matter if we look at the reduced form or the original. We can see that in the reduced form, degree on top is 1, degrees on bottom is 1. If we go to the original version, degree on top is 2, degree on the bottom is 2. So, regardless, they have the same degree, which means that they will have a horizontal asymptote. Now, write the equation of the horizontal asymptote. Since their degrees are equal, we will look for the leading coefficient in the numerator and the denominator. So the leading coefficient in the numerator is going to be a -1, or, yeah, I'm just going to put the -1 up there. Leading coefficient in the denominator is 3. So the horizontal asymptote is at y equals -1/3. Remember, there's 3 different cases for the degree, and look back at your notes or look at that Quizlet I sent you where I explained the rules of either the numerator is greater, denominator is greater, or their degrees are equal. Now it says use this information from A to E to sketch the graph. So what we're going to do is we're going to first, the domain, I mean, it's going to show up here, but our our vertical asymptote is right here at x is equal to -2. We have a hole at 0, 1/3. That's going to be right here. Our horizontal asymptote is at -1/3. So we can see that this graph is going to have this, it's going to dip down and go through the hole through here. If we wanted to plot a couple more points, we could. But now I'm going to pick a point on the left-hand side of the vertical asymptote. So -1, -2, 3. So let's see if we plug in x is equal to negative 3. What do we get? And again, we can use the reduced version of our function. So it's going to be negative, our y value there would be y is equal to negative 3 minus 2 over 3 negative 3 plus 2. That's going to give us, we'll leave this negative out front for now. Negative 3 minus 2 is negative 5 over 3. Negative 3 minus plus 2 is negative 1. This is negative 5 over negative 3. A lot of negatives to deal with. Over here in the fraction, the negatives are going to cancel. We're going to get negative 5 over 3 is just going to be our y value. So we know we have the point negative 3 comma. If we negative 5/3 would be, I think, negative 1.67. It's actually 6 repeating. But let's put that point there. Negative 1.67 would be something like down here. And we can see that, oops, that's not going to be a hole. That's an actual point. And then we can see that we get this graph right here.